Hello, my name is Ivan Taylor, and I'm a senior researcher in system dynamics at Policy Dynamics Incorporated in Ontario, Canada. And this is a presentation that I gave to the Adaptability Working Group in the INCOSE organization. It's similar to a presentation I gave recently to the Resilient Systems Working Group. I'm going to try to write a paper on this presentation and submit it to the International Symposium for 2025, the INCOSE International Symposium 2025 in Ottawa, Canada. So if you have any comments that could help me with working on this paper, I'd really appreciate it. Okay, so this paper is on the integration of system dynamics with SysML. I'm not an expert on SysML. I do most of my work is in system dynamics. I'm a member of the System Dynamics Society, and I'm a mentor in the System Dynamics Society, teaching the best practices of system dynamics modeling. But I've given many presentations on system dynamics to INCOSE, and I've been asked to discuss how system dynamics can be integrated with SysML, which is the modeling language of systems engineering. And here I'm going to talk about the specific application of this integration to adaptive design. So in the System Dynamics Society, we have a sort of a mantra that says structure determines behavior. And what I'm going to talk about today is how SysML can be used to determine the structure of a system that's being designed, and then if it could be integrated with system dynamics, we could use that structure and system dynamics modeling to determine the behavior of that system in operational use. So I'll get into my presentation. It'll start with a short introduction, and then I'll talk about system dynamics and behavior. Just give you an introduction to system dynamics if you don't already know. And then I'll talk about SysML and structure. And then I'll talk about integrating system dynamics and SysML. And then I'll talk about adaptive system design and the benefits of an integrated approach. And I'll have some key takeaways at the end. Okay, so as an introduction, I think we all know that systems are getting more complex, and there's always a need for adaptability, where adaptability is the ability to adapt to changing needs and conditions. And I believe that it's important to model both the system structure and the future behavior to build adaptable systems. So the purpose of this presentation is to explore the integration of system dynamics and SysML and emphasize the use of these two tools together in designing adaptive systems. So just in case you don't already know, system dynamics is focusing on behavior over time diagrams, where you have a parameter of interest, the variable, which is on the y-axis, and then time on the x-axis. And we use differential calculus to model the behavior of the system, in particular, that particular variable of interest over time with the system dynamics model. So as I said, it's based on differential calculus, and basically system dynamics models are highly connected systems of differential equations solved using numerical methods. And the way I often describe system dynamics is it tells you where you are today, how you got here, and where you're headed if nothing changes. But obviously, things change in the future, and we have to adapt to those changes. So system dynamics can be used to look at these kind of discontinuities in the future to see how the system would adapt to that, or how we can build a system that is designed to be adaptive in with changing needs and requirements in the future. The system dynamics uses feedback loops where a variable is utilized in the model, and when it changes, the change ripples through the system and comes back to where it started, with either reinforcing and or balancing effect. So the reinforcing effect is that the change in the system, change in the parameter goes through the system and comes back to the variable and causes it to increase even more or decrease even more. So you can have exponential growth or exponential decline. And then a balancing feedback loop ripples through the system, a change ripples through the system, comes back to the original value and inhibits the growth or balances the system so that it reaches an equilibrium over time, and generally is almost homostatic. So it uses stocks and flows, and stocks are the state of the system, which are basically in system dynamics, they're accumulations of a material or information, and flows are the way those stocks change, and basically their state changes in the system. And then we have time delays, which is very important because in system dynamics, you can model the idea that changes in the system don't happen immediately, that there could be delays that cause difficulty in interpreting the results and the impact of changes to the system. As you probably know, SysML is the language of systems engineering, or the modeling language of system engineering systems modeling language. And the way I like to think about it is that it works with structure diagrams. In particular, it's a standardized modeling language for systems engineering that uses diagrams like block definition diagrams, internal block diagrams, activity diagrams, sequence, and etc. And so I think that it does an excellent job of determining the structure of a system that you're designing. So why is there a need for integration of SysML with system dynamics? Well, it's because of the challenges of building and in particular modeling complex systems. SysML may capture the structure of a system, but it may not be able to project future behavior. And so by integrating SysML with system dynamics, we can get a holistic view of both the structure and the future behavior. So in terms of adaptable system design, adaptability ensures that systems can evolve to changing needs and conditions. And modeling adaptability with SysML and system dynamics, SysML supports the modeling of requirements, modularity, and change impacts, while system dynamics can project the system's nonlinear future behavior. So here's what I'm thinking about in terms of mapping system dynamics elements to SysML. As I said, system dynamics involves stocks and flows, and SysML has blocks and activities that might be comparable to stocks and flows. System dynamics has this idea of feedback is central to system dynamics, and this might be modeled in SysML using dependencies and control flows. And then, as I said, system dynamics is based on differential equations and possibly there's this idea of parametric diagrams, which actually can have mathematical formulas and constraints that might be modeled, that maybe help model in a system dynamics fashion. Now, this is a call for research and development, and there really hasn't been a lot of integration of system dynamics with SysML. There has been a fair amount of work on something called dynamical systems, which is not quite the same as system dynamics. And the work that I've seen on SysML and dynamical systems has been done in either of these two languages, either Modelica or OpenModelica, or Simulink, which is a product of the MATLAB group. And so there has been some work doing simulations of dynamical systems with these two tools. And so these tools, I think, advertise that they can do differential equations and stock and flow diagrams. So I think using these two tools might be a good starting point for integrating system dynamics with SysML. There's also been some work recently on Magic Draw, which you might be familiar with, and they're starting to work on building simulations as well. So maybe there's something there. If you're familiar with Magic Draw, you might want to look to that language to help integrate system dynamics and SysML. So the benefits of the integrated approach, as I said, it combines structure and behavior perspectives, and it provides a better understanding of future system behavior. And then I think this will really help to get, with these unified models, facilitate stakeholder engagement. That basically we would have a structure diagram from SysML so that a stakeholder understands what the system looks like and how it will be designed. And then we have a system dynamics model which shows the behavior of the system in operations and its ability to either be resilient against an adversity or possibly be adaptable to changing needs and requirements. So I think with these two modeling techniques and the integrated approach, we can get a lot of buy-in from stakeholders that these systems that we're designing will actually be able to do what they're stated to do and what they need to do based on the stakeholders' requirements. Now, there are some challenges. As I said, this is sort of a call for research and development, and one of the issues is tool compatibility and interoperability. Right now, I'm not sure if the tools are completely compatible, and interoperability could be an issue because, as I said, the tools that I use for system dynamics are not compatible with the tools for SysML. I'm not familiar with Modelica and Simulink, and I'll have to become more familiar with them. But even when we have system dynamics models and SysML models integrated together, we have to be very careful that these models are synchronized so that a change in the design will be reflected in the system dynamics model to see how that change in the design might affect the future behavior of the system. So there'll have to be some very heavy work on making sure that these two modeling languages and these two modeling techniques are synchronized. And of course, there's always a need for validation and verification. So verification would be that making sure that the modeling language actually represents the system and for example, in system dynamics, we want to make sure that the code that we develop in the system dynamics language or differential equations accurately represents the structures that we've identified in SysML. And then validation is important. Basically, where I think of validation is that we look at data from the real world and try to make sure that the modeling does reflect the data that we have from real world operations. And then also the other challenge is that this requires knowledge of multiple modeling methodologies. And so that's always a problem. There's a learning curve for these methodologies, and there may be some resistance to spending the time and effort to learn a new modeling methodology. So the key takeaways I want you to get from this presentation is the importance of integrating system dynamics and with SysML, and the benefits of doing that in designing adaptive systems. And I think there's a great potential for future research and development here. And I encourage this integration of the modeling approaches, system dynamics and SysML. And as I said, I'm writing a paper for the International Symposium of INCOSE in July 2025. The deadline for submission of that paper is November 30th. I have drafted the paper. If anyone wants a copy of the paper, they can contact me. Here's some references. You can contact me at this email address, ivan@policydynamics.ca, and I would appreciate your comments or questions. And even if the paper is not accepted by the reviewers of the INCOSE International Symposium, I still want to continue with this research, and maybe we can improve the paper for the 2026 International Symposium. So please contact me if you have any questions or want to get a copy of the paper that I drafted and want to make comments on the details there. So I thank you very much for your attention, and I'd love to talk to you about this again in the future.